While the law of sines is helpful, it's really of no use if we're given information about the three sides of the triangle or two sides and the included angle of a triangle, because we're always missing one of the pieces that we need for the ratios. But the law of cosines can handle these situations of side, 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 or side, angle, side. This is a representation of the law of cosines. We're using the traditional notation that we talked about in the law of sines. And you're going to notice it's very similar looking to the Pythagorean theorem. Let's look at a proof of this. We're going to take a triangle and then we're going to extend out and bring down our altitude to create a right triangle. Notice here that this angle, we'll call it theta, is our reference angle in the second quadrant for angle A. So from that, we can glean that the cosine of A is going to be this side here, which we'll call some value x over the opposite side here, or I'm sorry, over the hypotenuse, which is going to be b. So this length here is b cosine of a, and that's how they're getting the x value here. Likewise, the x value is the same for this point here, and our y value comes from the fact that the sine of a, or rather that reference angle for a, is the opposite over the hypotenuse, which is again that b. So b sine of a is then the value for the y coordinate. From that, we can then use our Pythagorean theorem. We know that it's a squared is equal to this side right here, which is c plus this, but notice that's a negative value for x. So that becomes c minus b cosine of a squared plus b sine of a squared is our y value. When we multiply everything out, we end up with c squared minus 2b c cosine of a plus b squared cosine squared of a plus b squared sine squared of a. Using some of our identities, I can factor out b squared here, which leaves me with cosine squared a plus sine squared of a, and that's coming from these two terms here. Plus, we still have c squared minus 2bc cosine of a. Remember from your identities that this is 1, so we're left with a squared is equal to b squared plus c squared minus 2bc cosine of a. And the other forms of the law of cosines can be proved similarly.